Solution of right triangles. Right triangle is one in which one of the angles is 90 degrees. Here is a right triangle. Here is the right angle and the hypotenuse, which is the side opposite to the right angle and is considered the longest side. Consider one of the acute angles, not the right angle, here. Name the other two sides relative to that acute angle as the opposite and adjacent side. The length of the sides of a right triangle are used to define the 6 trigonometric ratios. Here is our right triangle with a right angle, an acute angle theta. We have the side opposite to theta, the side adjacent to theta, and the hypotenuse side. The 6 trigonometric ratios are sine, cosine, tangent, cotangent, secant, and cosecant. Let us define these 6 trigonometric ratios. Sine equals opposite over hypotenuse. Stands for SO. S is for sine, O for opposite side, H for the hypotenuse side. Cosine equals adjacent over hypotenuse. Stands for CA. C is for cosine, A for adjacent, H for hypotenuse. Tangent equals opposite over adjacent. Stands for TOA. T for tangent, O for opposite, and A for adjacent side. Cotangent equals adjacent over opposite. COW stands for C cotangent, A for adjacent, O for opposite. Secant equals hypotenuse over adjacent. SHA. S stands for secant, H for hypotenuse, A for adjacent. And the last ratio is cosecant equals hypotenuse over opposite side. SHO. C stands for cosecant, H for hypotenuse, and O for opposite. Again, try to remember the acronym SO, CA, TOA, COW, SHA, SHU. There you go. Let us apply these functions in finding the 6 trigonometric functions of acute angles alpha and beta. Consider the right triangle shown. Sides given 3, 4, 5. Let us first find the 6 trigonometric functions of alpha. Sine alpha equals opposite over hypotenuse equals 4/5. Cosine alpha equals adjacent over hypotenuse equals 3/5. Tangent alpha equals opposite over adjacent equals 4/3. Cotangent alpha is just the reciprocal of tangent alpha. Its cotangent alpha equals adjacent over opposite equals 3/4. Secant alpha is just the reciprocal of cosine alpha. Secant alpha equals hypotenuse over adjacent equals 5/3. And cosecant alpha is just the reciprocal of sine alpha equals hypotenuse over opposite equals 5/4. Please take note of that. Cotangent is just the reciprocal of tangent. Secant is just the reciprocal of cosine. Cosecant is just the reciprocal of sine. How about considering another acute angle beta? Sine beta equals opposite over hypotenuse equals 3/5. Cosine beta equals adjacent over hypotenuse equals 4/5. Tangent beta equals opposite over adjacent equals 3/4. Cotangent beta is just the reciprocal of tangent equals 4/3. Secant beta is just the reciprocal of cosine equals 5/4. Cosecant beta is just the reciprocal of sine beta equals 5/3. Let us have another example. In the triangle shown, find the sixth trigonometric function value of acute angle A if side A is 12, side C is 13. We have a missing side, which is side B. We cannot find the six trigonometric functions if we do not know all the three sides. So what is the first step? Find the missing side. How? Use the Pythagorean theorem, which states that a square plus b square equals c square. Looking for b, it is b square equals c square less a square. Substituting the value of c, which is 13, and substituting the value of a, which is 12. B square equals 13 square minus 12 square. And b square equals 169 less 144. B square equals 25. B equals square root of 25. And there you go, b equals 5. Since we know already the value of side b, we are now ready to solve for the sixth trigonometric function of acute angle A. Here we go. Sine A equals opposite over hypotenuse equals 12 over 13. Cosine A equals adjacent over hypotenuse equals 5 over 13. Tangent A equals opposite over adjacent equals 12 over 5. Cotangent, just the reciprocal of tangent, equals 5 over 12. Secant A, reciprocal of cosine A, equals 13 over 5. Cosecant A is just the reciprocal of sine A, equals 13 over 12. Let us have another example. Solve right triangle ABC with right angle at C. An acute angle A measures 35 degrees. Side C measures 15 units. To solve the triangle, find the value of the remaining sides and angle, and that is angle A, side A, and side P. Let us have here finding for the acute angle B. We know already that the sum of the three angles in a triangle is 180 degrees. We will be using that theorem, so A plus B plus C equals 180 degrees. Solving for B, B equals 180 less 90 less 35 degrees. B measures 55 degrees. We are now going to solve for side A. Using trigonometric function sine. Sine A equals opposite over hypotenuse. Sine A equals A over 15. Substituting the value of acute angle A, which measures 35 degrees, sine 35 degrees equals A over 15. Solving for A equals 15 times sine 35 degrees. A is approximately 8.60 units. We are now ready to solve for another side, B, using function cosine A. Cosine A equals B over 15. Substituting the value of 35 again, in place of acute angle A, cosine 35 degrees equals B over 15. Solving for side B equals 15 times cosine 35 degrees. B measures approximately 12.29 units. We already have solved the triangle. Let us have another example. Again, solve right triangle ABC with right angle at C, where A measures 30 centimeters and C measures 54 centimeters. Again, to solve the triangle, we have to find the remaining side, which is side B, and two acute angles, angles A and B. We are going to find first the remaining side, which is side B. Using the Pythagorean theorem, which states that a square plus b square equals c square. Looking for b square equals c square less a square. Substituting the value of c and a to the equation, that becomes b square equals 54 square less 30 square. B equals 12 times the square root of 14. Since we know already b, that measures 44.90 centimeters approximately. We are now ready to solve for angle A using sine function. Sine A equals opposite over hypotenuse, and sine A equals opposite side measures 30, the hypotenuse side measures 54. So A is equal to the inverse function of 30 over 54. The value of A is approximately 33.75 degrees. Let's find for acute angle B. Let us use the function cosine. Cosine B equals adjacent over hypotenuse. Cosine B equals adjacent side measures 30, hypotenuse measures 54. Substituting it to the equation, we have angle B equals inverse cosine of the quotient 30 over 54. Acute angle B measures approximately 56.25 degrees. We were talking about reciprocal functions. I want you to take a look at this. And please try to remember it. Cotangent again is the reciprocal of tangent. Cotangent theta equals 1 over tangent theta. Secant theta is just the reciprocal of cosine. So secant theta equals 1 over cosine theta. And cosecant theta is just the reciprocal of sine. So cosecant theta equals 1 over sine theta. Let us use that in this example. Given that sine theta equals 4/5, cosine theta equals 3/5, and tangent theta equals 4/3. We are looking for the three remaining functions. cosecant theta, secant theta, and cotangent theta. Here we go. Cosecant theta is the reciprocal of sine theta. That is, cosecant theta equals 1 over sine theta equals 1 over 4/5 equals 5/4. Secant theta equals 1 over cosine theta equals 1 over 3/5 equals 5/3. Cotangent theta is just the reciprocal of tangent. So cotangent theta equals 1 over tangent theta equals 1 over 4/3 equals 3/4. Just as easy as that. That ends our lesson for today. Thank you for watching. See you around.